Hi, today we're going to talk about mesh analysis. We can see that in this case we have voltages but with a cosine and an angle. So we need to change this to phasors. This one is going to be 20, angle of 15. This one is not a cosine, it's a sine. So it's not going to be the same angle as here. In this case, it's going to be 15 angle of negative 105 by rule. And the next one is going to be 40 angle of minus 50, because in this case, yes, it's a cosine. So in mesh analysis, what we need to do is divide all the mesh, which this is one mesh and this is another one. So in this case, I'm going to use this one as I1 and this one as I2. We have two meshes, and as we know, Kirchhoff voltage law, we can apply that on here. So we're going to start from here on mesh 1. It's going to be negative 20 angle of 15 plus 100, which is this one, this resistance, 100 times I plus this one we need to change it, so we need to change it to imaginary with the J, and we already know how to do that. So if we do the calculations, we get J70 times, it's important to multiply this times I1. Then we do the same on here, plus J80, on this case the number is 80, times I1, but we can see that this value is in between these two meshes, so we are going to subtract I2 plus this resistance 150 times the same I1 minus I2, right? And then this one, that we need to do it as on the beginning, we need to use the phasor, is going to be minus, because we can see that here the correct minus 15 angle of negative 105. This is the phasor. So we can use our to get the values with the C-solve, and answering the values we get that I1 is 0.0746 and 44. I2 is 0.244 angle of 125. Well, these ones are amperes. As we know, the units are very important. And we know that IA it's equal to negative IB. So we can say that this is going to be 0.244 angle of negative 65 amperes. Once we have this, we can change it as follows. We write the magnitude 244, cosine of 20t, which is where it was originally written, and we need to change the angle as the one that we found, 65. All this is amperes. This is on time. And as we can see on the circuit, IB, we can find IB by subtracting I1 minus I2, because here enters I1. Here goes out IB, and I2, we can see that is here. So we can write it as follows. IB, it's equal to I1 minus I2. And the result of this, after doing the calculations, is 0.1716, angle of negative 49 amperes. After this, we know that VB, voltage in B, you get to see here, is going to be negative J80 times negative I2. It's important that you need to know why this is the sign. So we get the voltage in B, and it's going to be 19.52 angle of negative 145 volts.